technical difficulties?
Yes.
So using the 2 sample variables.
Right. I'm just finding that's the question, so I don't want to do that. Let me find the window that has salt in it. There. Hey, that's not got salt in it. This got salt in it? No, that's not got salt. I'm trying to find the window. Hang in there.
Okay.
Should be this window. Why can't it? Oh, because it's on the other page. Okay.
I appreciate you doing that for me.
Not a problem. You might hear me swear in a minute as I try and get to behind the window, because there's a window in front that doesn't want to move. Got it. There we go. Right. So close. What was it you wanted me to go over again?
If you can just show, I mean, even if it's just one of the problems again, using the
salt.
Yes.
Is it to create like a 95% confidence interval?
No, it was like using I don't need the t-distribution part, and that's hold on, let me pull up my screen. It's the one with the 2 sample variables for the 2 sample t's and to find the standard error and that type of stuff.
Okay, so I don't know what you're saying. Are you saying the 2-page thing right now, or should I?
Yes.
Okay.
Yes.
So what you've got here, I'm going to, if you don't mind, I'm going to pause, mute you, because we are getting some heavy background sounds. Even better. Thanks, Amber. So let's do question 7 since it's in front of us, and maybe take you through the whole process from start to finish. That one's got most of the numbers. Let's pick one that you get less stuff with. Right. Let's do one higher. Okay. I should be able to get one up here somewhere. No, they're just general. Okay, let's do question 4. And so this is another one of those cold stories. And so I've got 2 populations. And the first one are going to be the people who get zinc. And the second one are going to be those who get the placebo. And so what I'm doing is I'm going to read through this question and write down all the relevant information. "29 participants took the zinc. So the sample size for zinc is 29. 27 got the placebo. So the sample size for the placebo group is 27. I'm now going to find the mean of these. And we read that, and in this story, if everyone in the pub took zinc, the symptoms lasted 4.5 days. So for those who took zinc, their cold lasted 4.5 days, and the standard deviation for those people was 1.5. And then if we do the placebo group, they lasted 6 days with the cold, and their standard deviation was 2. Okay, are we good with all those numbers, where I got them from?
Yes, so X1 would be 4.5 standard error, right?
Mm-hmm. Yeah.
Okay, perfect, yeah.
Right, so what we're now going to do is take all of that information and we're going to use it to create a 95% confidence interval, and to find out what the standard error is, and to find out what the difference between X1 and X2 is, right? That's typically the 3 main questions that you get. So you go to inferential statistics, and then you choose 2 sample T. And then on the first group, the mean was 4.5. The standard deviation was 1.5. Oh, there's one there already. 1.5, and there was 29 in this group. And then the sample 2 had a mean of 6. The standard deviation for that placebo group was 2. And the sample size for that group was 27 people. Are you comfortable about how the 6 numbers I've got, where they came from in the story?
Yes.
Okay, so now we move down to click on confidence interval. and make sure that's whatever it is, in this case 95%, which is pretty much what they always seem to do. Now this little box here, assumed equal variance, that box is going to be left blank unless you get a question, and there was only one of them that I recollect, that specifically says pooled data or use pooled data. It had that phrase in it, use pooled data. If it doesn't mention anything, or it says unpooled data, because I think it mentioned that in one of the questions, leave it blank. So the quickest way for me to figure out what to do is, if it says pooled data, use it. If it doesn't say pooled data, those words exactly, don't use it. So now I can generate results, and everything I need to know is here. X1 bar take away X2 bar is this number here, it's the difference. The 95% confidence interval starts at negative 2.45 and it finishes at negative 0.54. The standard error is 0.475. So if we click out of that, right, the mean is technically the mean difference, but they just wanted to call it mean, so it is. Goes here. The standard deviation, which is what that is the standard error, just its other name. And you want this one here to, what, 3 decimal places. So 475 is 475. One of these pictures has this look to it, right? So I have a 1.5 and I have just realized, and I can't do much about it, but I got them back to front. You see it said placebo take away zinc, and I did zinc take away placebo. Can you just pretend that the numbers were the other way around? So the difference would be positive 1.5. Is that okay, or do you want me to retype the numbers?
No, I get it.
You get it, okay. So I just put them in the way they said it, but for some reason they switched them on me. So are you comfortable with how you get the mean, and the standard deviation doesn't care which order they're in?
Yes.
Right, now one of these pictures is going to have a 1.5 in the middle and roughly go up by that amount. So I'm looking for a 1.5 in the middle, and the only one that has that is the top one or the bottom one, right? And since the standard error is 0.45, that's roughly, you know, kind of 0.5 kind of thing. And so I'm looking at it. Would you agree this one looks a bit more like it? And so choose that dot instead of the top one. Now, in this interval, they go in and I think they're just repeating the information. The sample difference is 1.6, was it? Yeah, it's 1.6. Did I miscount that or mistype that? This 1.5. $4.56. I'll make it 1.5. Let's see what's going on here. In the study, the sample mean duration of the symptoms was 4.5 for 29 and the 2 zinc, and 6.1 days for 27 beta park, for a difference of 1.6. Okay. Evidently, they've changed the story, but the difference between these two is 1.6. I'm not going to argue with it. Is this difference reasonable based on the figure you just drew? Right. I guess the only thing that matters is they did it again, and they got, on the second time they did it, they got a difference of 1.6. Now, if you look at this picture, would you agree 1.6 is really very close to the middle?
Yes.
Right, so I wouldn't be surprised if that happened, right? If I did the same thing a third time, but the difference was 14, wouldn't I be really worried? Because that's way over here. And I'd say, I think I screwed up here somehow. That's not what you'd expect. Wouldn't you typically expect somewhere in this kind of big picture range here, right?
Yes.
So a sample difference of 1 point falls. I think it's just above, isn't it? Yeah, just above 1.5. And then it says, and this corresponds to a z-score of. Right, this is a piece of information a way back in the day. Can you remember the formula for getting z-score?
Not off the top of my head.
Right, here goes. It's data, take away the mean, divided by the standard deviation. So the data in this case was the difference of 1.6. And the mean in this case was 1.5, right, that guy there. And the standard deviation in this situation is called that. So it's going to be 0.475. Now I'm going to close that guy off, if I can find the darn window, here we go, and show you the z-score, because you can't really do that with salt. I think that's one of the few questions where they actually got you to do it. So data, take away mean, divided by standard deviation. I go to my calculator and I do a little bracket around it for safety. 1.6, take away 1.5, close the brackets, divided by 0.475, and I get the answer of about 0.21 to 2 decimal places. Now, when you did z-scores a long time ago, aren't z-scores standard? And they go 1, 2, 3, -1, -2, -3. Remember that picture? It looks something like that.
Yes.
Would you agree a z-score of 0.21 is totally normal kind of number that you'd get for a z-score?
Yes.
And so that sentence says this is totally normal. Its z-score is 0.21 and it falls within a reasonable range. Suppose I did a different one and I got a 3.5 as my z-score. Why would I consider that exceptionally rare and a little bit unusual? Let's phrase it differently. What range of values are z-scores typically in? There's a number for the z-scores. Between what two numbers is it normally within?
0 and 1.
Mm-hmm. If I called you an outlier, what kind of z-score would you have to have? That's a different version of the same question. So any z-score greater than 3 or less than -3, because it could go the other way, is considered an outlier, is considered exceptionally unusual. Any number that's kind of in this range, couldn't it happen? It will happen, you know, at least now and again. So that's where that last piece came from. You got a number of 1.6. How unreasonable is that? Well, if the normal number is 1.5 and you got 1.6, the z-score came out as a relatively boring 0.21. So yeah, nothing to see here, nothing weird. A different story, the z-score is 3.5. You would be saying, that is a weird result. That isn't the kind of number you would normally expect from the information that you were given. And that's it.
Perfect. Thank you so much.
Okay. So I will leave you. Any other questions? Anybody else? Are we good to, oh, Isabel?
I don't think I was talking first, but I do have several questions. I just sorry to bring you back to these two assignments, but for the chapter 9 sampling for distribution means, I had
Yes.
two questions that I was still stuck on and couldn't figure out. And then on the single mean homework for chapter 11, there was 3 I was also stuck on. So I have 5 problems.
Okay. Well, we might keep you to the end then.
Okay.
Anybody, the other 2 good questions? If you're just hanging about to watch, that's fine. If you've got a question, maybe I should answer that one first, and then I'll finish with Isabel. Crystal?
Hi, I have a question on the chapter 11, the first one, the estimating the value of a single mean.
Okay, let's go hunting for that one, because that might be an overlap for one of your questions as well. That can happen sometimes. Right, I'm going to have to wait a few seconds while I go hunting for the window that I need.
Okay.
Right, so chapter 11, single mean, loading that up as we speak.
And then question 15.
Right, well, do question 1 and 15. Gotcha. Single mean view. Open it up. Put on the key. You said question 1?
15.
15. Oh,
Yep.
okay, that's second last question.
Yeah, because for mine, I have a standard deviation of 1. So for the first one, wouldn't it be like 28 and 30?
Could be, I don't know yet. No,
Oh,
they
sorry.
don't. They don't have a standard deviation in 1.
This is the question that I messed up on a lot because I rounded earlier. So just make
That might be what happened then.
that
Right.
you're doing
Yeah.
your values to like 5 decimal places just in case, and then don't round it until the very end. And then the answers might be like slightly different, very different, but very close to what you already have. I remember I had some pain on that one too.
Okay.
Okay.
So in the question that you're looking, I think I'll zoom over to the question so that when I speak, you may be able to see what I'm talking about. Right. So this here is the question, and these are the numbers, at least for this version. Right. Now, what is the standard deviation? Well, it's not 1. The standard deviation of the sampling distribution is the standard deviation divided by the square root of n. Right, so since there's 24 here, you want to do 1 divided by the square root of 24. And then as Isabel was saying, be really accurate. Don't just call it, 0.7 or something, right? Call it 0.2133. And if you do that, one of them will give you this interval, plus or minus 2 will give you this interval, and plus or minus 3 will give you that interval.
Yeah, but I would honestly use it to like the 4th decimal place or the 5th, because I did it with just 3 decimal places when I rounded, when I was doing like when I multiplied. So like I rounded the answer to 3 decimal places, and then I multiplied it by 2 and 3 for whatever intervals.
Right.
And it was wrong because I rounded it. So just, yeah.
Oh.
The answers are supposed to be 3 decimals, but calculate.
But the
4
working should be 4 or 5 to be safe.
Yeah, that's all I'm saying.
Okay.
Agreed. Right. So just do the calculation. Standard deviation, in this case 1 divided by the square root of the sample, in this case 24, and plus or minus 1, plus or minus 2, plus or minus 3, and do it to at least 4 decimal places before you round off, and you should get values that look like this.
Okay, thank you.
And what was your other one?
I just had one question.
Okay. You can hang about if you want then. Isabel, where should we start? And we're on 11. Is there any
You're
more
right.
than 11
You're right
first?
there. 13, 14, and 16 of this homework. So
Say it again, question 13.
13, 14, and 16 of this homework.
Okay, let's start at 13. Describe the sampling distribution for the statistic of interest. So isn't the sampling distribution has a mean that's the same as the population mean, and it has a standard deviation, also called the standard error, of S over the square of n. Okay, so let's see what we have. A fisherman takes tourists on a fishing trip and has noticed that on the long run, the weights of certain type of fish is typically caught is approximately normal, and the mean is 13 pounds, and the standard deviation is 3. Now, during a good day, a boatload of 8 people catch 2 fish each. So that's another way of just telling you that the sample is 16. So the mean of the sample
deviation is 3, the mean is 13, and n is 16.
Yeah, correct. So
Okay.
you go 3 divided by the square root of, in this case, 16, and that's where 0.75 comes from.
Okay.
Now, in the next story, I think it's going to be the same, but let's read it in case it's not. A fisherman hangs out at a local bar in the evening and hears tourists talking about the weights of the fish that they caught. Well, we all know that people kind of exaggerate when they're fishermen, so it might be to do with that. He notices that the weights mentioned seem to have a mean of 25 pounds and a standard deviation of 4. And he records what he hears about the weight for the next 70 fish stories at that bar. And the statistic of interest here is the mean of the 70 stories. Assume that they represent a random sample of all such stories. Let's see what we can get. The sampling distribution of the mean weight for n equals 70 is approximately normal. Why? Because the data is approximately normal, right? It's a hill, symmetric.
Yeah.
The mean of the sampling distribution is going to be the 25 pounds. Now, the standard deviation, also called the standard error, it's got lots of names, is going to be made up of the standard deviation divided by the square root of 70.
So 4 to 5, yeah.
So all we need to do is find out that guy and get this answer.
Okay, and then that was 13. That makes sense.
Okay, so where's our next one?
14.
14. Okay, so in this story, the medical journal states that the mean amount spent per person on prescription drugs is about $480 and that the standard deviation is 58. So they took a random sample of 150 of them and estimated the mean and drugs every year, and they found out it was $490. So we're going to see how that compares to what they believe to be true, right? Calculate the mean of the sampling distribution. It should be 48, the population answer.
494, because I think
That,
that's
yeah, that 490 came from, they believe the answer is 48, right? And so to test if that's really true, because you believe things and they were true 2 years ago, but they might not be true anymore, right? It might be.
Is it the sample mean?
Right, so that is the sample mean, yeah. That's the sample of the 150 people that they found out, what did you pay in prescription drugs? And on average, they paid $490. You see, it's a little bit different, right? A little bit more than that. But I guess the question they're going to ask is, how unreasonable is that, right? What would you expect? So to calculate the standard deviation of the sampling distribution, right? It's 58 divided by the square root of 150 people. And that ends up being 4.7. And then they say, write a probability statement that can be used to calculate the probability of getting this. So we're going to find out how unusual it is to get $490 as an average from 150 people. Is that reasonable, or is that really weird? Because if that's a really unlikely event, then maybe we should look into this number, because it looks like it might not be true anymore. So what's the chances that you get a guy greater than or equal to 490? So what's the chances that a sample is bigger than 490? Now you want to calculate that. I need to write down some numbers here. The mean is 480. The standard deviation is 4.7357. And I want to find what's the probability that you get a number greater than or equal to 490. So I've got all the numbers, now hit solve. Normal distribution. The mean, 480. That's what we believed it to be. The standard deviation, we calculated to be 4.7357. We want to know what's the probability that you get bigger than, so it's a right tail. And we want to know what's the chances that you get bigger than 490. And the answer that we got was 0.01736. Unfortunately, I think I've lost. Yeah, that's what happens when you do this. I have lost. Oh,
It's okay. I saw it.
right, okay. So you just go back in. Oh, it's still there, good. And you put in there. Well, before that disappeared, did you see it fitted the answer?
Yes, I did. And then I needed help on a part of 16. I think 16B, just the,
Right, so 16A, blah, blah, blah. 16B, this guy here.
yes.
Now, would a mean of, in my case, would a mean of 7.3 hours of sleep obtained from the statistics above be reasonable? For a sample of 197 adults. So I'm assuming that you've done all the calculations up here and you got your thing. Right. If you look at this picture, a mean of 7.3 would be reasonable value to expect. That's what they say is. If the population mean is the same as it was reported, then the mean reported statistic would be 1.69. See this bit here, the 1.69?
Yeah.
It's essentially the Z-score.
Okay.
See, if a Z-score is 2, it means you're 2 standard deviations away from the mean. If your Z-score is 2.9, you're 2.9 standard deviations away from the mean.
And to get the Z-score, it's data minus mean over what?
Over the standard error or standard
So what's the
deviation.
data in this case?
The data in this case would be the 7.3. The mean would be, oops. Where's the data? Let me. Where is the mean?
Isn't it 7.3?
Uh-huh. Well, see, the 7.3 is the sample. I'm trying to find the mean of the population. There it is there.
Oh, yeah.
So it would be 6.95.
Is that the sample mean?
That's the population. The sample is the 7.3. Oh, get it right. Is 7.3. You were right. 7.3. Take away the 6 point. I think it was 95.
Yeah.
And then you're going to divide it by the standard error, which was calculated or should have been calculated somewhere. And I haven't got it handy, but to get the standard error, don't you take the standard deviation and divide it by the square root of the sample? So is that anywhere handy? There's the standard deviation, right? 2.85 divided by the square root of 195. I do not know what that number is.
97.
But if you
I'll do it real quick.
right.
It's 0.20305.
Okay, so 0.2035, whatever you said. So if we do that calculation, we hopefully will get what we're looking for. So I have 7.3, take away 6.95. So 7.3, take away 6.95. I get 0.35. I'm then going to divide it by 0. I think you said 203. Did you say 203 or 2035?
203.5, yeah.
Right. So I guess I should be more accurate.
Wait, 203.05. My
Okay.
bad.
Well, try that one. And you get an answer around about 1.69, depending on how you round off.
Okay.
At least in this question. And that is well within the reason. If you get a Z-score between 3 and -3, doesn't that mean it's okay? It's within reason. If it's bigger than 3, then you would change that
Oh,
to
okay. I
not
was
within.
wondering what that was like asking. Okay.
Right. So Z-scores essentially allow you to find out how unlikely one specific sample might be compared to what you would expect based on the information that you're given about the population.
Yeah.
Okay, where are we off to now?
Can we do in the chapter 9 homework, number
Sure.
7 and number 10?
7 and 10 coming up.
Yes.
Oh, this is much shorter. Okay,
Yeah.
I got 7. Stop sharing. I don't know. What are you looking at right now? You're looking at
I'm
7,
looking at the WebAssign screen.
but can you see 7? No?
Now I can't. Now it's just the Zoom.
Okay. Can you see it now?
Yes, I can see it now.
Okay, so 7 says, describe the sampling distribution for the statistic of interest. And let's see what, and including the mean and standard deviation, right? When they use the word standard deviation, it's normally because the numbers you're using are coming from a population. And when they use the word standard error, it's because the same kind of numbers, but you got those numbers from a sample. So it's linguistic, like they are the same thing. They're both standard deviations, but they give them slightly different names because of where you get them from. So that's that's why sometimes I'll call the thing standard deviation, where if I'm being really nitpicky, I should call it standard error,
Okay.
right? But
So-
it's still a standard deviation, and it does what standard deviations do. It just means it came from a sample. So back to the story. A fisherman takes tourists out. It's another fisherman story. And what do we know about the mean is 13, so 13 goes there.
Yes.
It is approximately normal because they told you somewhere that it was normal in shape, or we assume that it is. In this case, it ends up being 16. So this fella is going to be the standard deviation, 3, divided by the square root of 16.
Which is 0.75.
Which is what they got. And this one, they just changed the story to be 60 fish. And the average this time is 27. So you see 27 now?
Yes.
And to get 60 fish, it's going to be the standard deviation of this story. So what's that, 4 this time? And 4 divided by the square root of 60 fish is like 60 in your sample. And that ends up being 0.5164.
And it ends up being what?
0.5164, at least in this question, with the numbers they gave me.
And that's for that last little bit, right?
Yeah, that's for calculating the standard deviation.
And the 27
sampling.
is just the new mean, right?
27 is just a new mean, correct? Because in B, they changed the story. A new mean and a new sample size, right? 27 out of 60, and the other one was 16, you know, out of whatever, 13 pounds with 16 people.
Okay. Okay.
And question 9,
It was 10. I think I got 9.
oh, 9 is picture, right? 10. Okay, so, oh, it's kind of similar to one we did earlier. A recent article published in the medical journal. Oh, this is exactly the same question. Am I in the same question?
No, it's
Did I forget to change?
different.
No, it's probably the same question with different numbers. Okay.
Yeah, I think so, but
Yeah. Okay. So in this world,
anyway.
right, in this world, the population is 500. Check. And the standard deviation is going to be 52 divided by the square root of the sample size. Now, in this one, the sample size is 150. So if you take 52, the standard deviation of the population, divided by the square root of the sample size, you will get, in this case, 4.24.
Okay, wait, that'll give me. Okay, I see something. Okay.
Now,
and below, I got that, and then at the bottom, how do I use salt to do that?
Okay, so in C now, what's the chances that you do a sample and you get 490 or more? So 490 more look like that. And I need to keep track of my numbers. The mean is 500 and the standard deviation is the 4.2458 that we found in A and B. So I'm going to use that number as the mean and this number is the standard deviation. And I'm going to find the chances that you get a mean bigger than 490. And it better be 9907 when I'm finished. So here it goes. So we go here, normal distribution, click on this guy, 500. Click on the standard deviation, 4.2458. Go here. Do I want to go here? No, we want bigger than, so we want a right tail test. And we want to find out what's the chances that it is bigger than, I believe it was 490.
Yeah.
And there's that 9907 that I was looking for. So the probability that you get something bigger than that number is going to happen about 99.075% of the time.
And we got that standard deviation, earlier from when.
Early from, that was B in the answer.
See where we got it from. I was like, where'd that come from? But I see now, because
Okay.
for some reason in my head, it seemed like a different question, but it's the same question.
Okay, I've lost that question because I can't get back to it, but that would be it.
And then I think, sorry, I have
Mhm.
so many. I just want to make sure because there's just a lot. And then I think 11, the 2 means 1, so like the second chapter 2 homework.
Okay, which ones have we not covered yet?
I think, because I feel like we covered all of them except the last couple. Could we do the last couple? Because I think
We did the second last one right at the beginning of today. So-
it goes
So
up. To,
if you missed that one, you could probably just watch the video on it. But here's, I'll show you the answer to it. And the last one is just a sentence, which is a pretty standard sentence. So hopefully that's not too bad. Right. We'll do it backwards. Question 13 then. The paper, How Happy Was I Anyway, is a retrospective impact bias. Evidently somebody is looking into people's recollection of the past isn't necessarily the same that they have now. So if I asked you a question 4 years ago, how happy do you feel? And I gave you a scale of 1 to 5. And then in 10 years or whatever, I went and said to you, 10 years ago, Isabel, how happy did you feel? Can you imagine that your reflection on the past might not be the same as your reflection when I asked you right away?
yeah.
And that's called retrospective impact bias. They all have names for everything, right? And the reason it's bias is that you aren't any happier or less happy when I asked you. It's just your recollection of it has now changed.
Yeah.
So
We covered 8 in class today, right? Because I think I was having trouble with that.
we did all the way up to
Okay,
8.
then I'll have notes on it. I think that's it.
That's it.
Awesome.
Okay.
Thank you so much. This was super helpful. It's like
Not a problem.
a private tutoring session.
Do you mind if I
have a good
use
rest of
this?
your
Yeah,
day.
do you mind if I use this as part of our video? so
Oh,
people-
absolutely. And I'll let people know. Because I have a little group chat with some of the classmates. I'll let them, because we help each other out. We're like, hey, can someone help me with number 13? In between the class dates. But
that's cool. I like
yeah,
that.
but I'll let them know that there's some extra help at the end.
Okay. And this one probably won't get online until tomorrow. So they should
Okay.
look for it until then.
No worries. Have a
Okay.
great rest of your day and a good
You too.
weekend. I'll see you on Monday.
See you Monday.
All right, bye.
Bye.